Hey, this is Printrbot with Printrbot.com, and we have a CNC test running, and we have a Printrbot test running, and I'm probably going to have to quit. Printrbelt. Anyway, this is the CNC that I was working on from last week, and I guess I should welcome to the Printrbot live on Facebook, and not live elsewhere. Brickdrum from Printrbot.com, and this was something I mentioned last week. I'm going to turn this off in a second because it's just a demo. I didn't want to cut in here. In fact, I'll turn it off now. You can see that it works, but this was just parts laying around the shop. I wanted to get back into CNC and have something that was small for your desktop that is very affordable. So I got so far, I've reconfigured it a little bit, and I have, I've got the X and the Y going on lead screws, but I haven't yet made the design that I have for the Z on lead screws. So right now this is just running on belt, which is not going to work. I knew it wasn't going to work, but I wanted to see it move first. So I've got the X and Y done. I'll get the Z next, and then I'll put together a kit, hopefully for next week. We'll be able to actually offer the bare bones stuff if you want to build your own kit. So another week's wait until you get the files and can order a product with the bars and the bearings and such. But I think I've got a kit figured out that is just fun, cheap to get started. And I've called it the Adoptabot CNC. We may call it something else in the store, but the idea is, for those of you involved in the Adoptabot program, it's really for kids, for schools. And the idea is donate one to a school. Whether or not you donate this, I'm not going to do a hard press on that. It's fine if you want to just get a CNC that's inexpensive, not made in China, involves you putting it together, and you're a maker and you want to try it out. So one of the cool things I did try is I finally got this working with CNC.js. And that is a JavaScript program that you can run it on your computer. You can actually run it on a Raspberry Pi, which is pretty cool. So you could have a Pi. This is just a printer board. And the thing I found out from using CNC.js is that you can design and path in Fusion 360, which is what I'm used to. I'm not used to pathing, so I had to watch some tutorials on how to do it to kind of refresh my memory. It came back pretty quick, but I'll try to get some parts cut on this to show you, and I'll just do wood for now, to show you that it's totally possible using YouTube videos to learn how to CNC. You get your G-code file, and you can put it into CNC.js, and then I got that far. And then I was like, okay, now what do I have to run on my printer board to control this? And I looked over in the connection side of the CNC.js, and there it was, Marlin. There was a button for Marlin. I was like, what? I don't have to load Gerbil or Gerbil or whatever you call it. I don't have to reload something on my printer board to run a CNC, and the answer was no. So I left I think it was set up for a simple. I left that on there, and I connected, and it said waiting for, I loaded it wasn't a pathing file for cutting something in CNC. It was just a test cube print for a 3D printer. And it said, hey, waiting for hot end to warm up. So I threw a hot end on there and plugged in the thermistor. And when it got to 200 C, it's like dangling underneath there. When it got to 200 C, it just started cutting, as it were. Printing was really what the intention of the file was. But it started moving around and cutting. So all I'd have to do is hook up the Dremel. I'm going to actually build this for a router. So that's what you'll see hopefully next week is an actual router on this, because I think it's strong enough to run a router and cut wood. And the Dremel thing is kind of cool. I just have it zip tied on here. But really, if you're going to get into CNC, this is my opinion, and I've already told you I'm a novice. So don't mess around with a Dremel. Don't mess around with a spindle. The easiest thing is get a router like the Crawlbot has. I'm going to get a DeWalt, actually. I think it's a 611 model or something like that. It's accepted in the community of CNC for cutting wood. It has some options that you can upgrade. You can control the spindle speed with a separate unit that you buy to control the spindle speed. So I'm going to get into that next week, but this will be a little bitty router with a small cutting space that has, it'll be, the router is about that wide, so it'll limit the area that it cuts, but you'll be cutting actual parts if you get this kit. And I'll keep it super cheap so that, a lot of the parts you'll have to go get your own wood. But as far as the motion, the lead screws, the bars, the essentials to get it going with, and by the way, I'm using printed parts on this. Maybe I'll upgrade this to make its own Delrin parts. You can machine your own Delrin parts and replace the printed parts, because really you want either metal or plastic machine parts to have a really, really rigid CNC. But having a lot of fun with this. So that was the first thing I wanted to show you. Are there questions on this? What do you think the price will be for the Adoptabot CNC? So what I'm trying to do is keep in the bare bones kit, meaning you have to have a 3D printer and print parts, and you have to go buy your own wood, and you have to buy your own router. So with that, the parts are going to be very cheap. I think it's going to be a $99 kit. Again, I'm not putting metal parts in here, so it's printed parts. I might actually include a laser cut part just to mount this to, but I might be able to get that done in 3D printing as well. So it's really going to be a 3D printed wood router kit with some metal parts, and it'll be under $99, either under $100. So I haven't decided yet, but it'll come with electronics, a printer board. I won't have to use an F6. I'll use one of the older versions. And you can load Gerbil on that. If you can figure that out, I haven't done it yet. I don't think there's any need, but I'm gonna research that. There is a version of Gerbil that loads right onto the printer board, and you can control it. So electronics and bars and bearings, and you'll be good to go to build your own CNC. So $99, man. Oh, by the way, there will be 3. It's XYZ motors. So you'll get the motors, get the lead screws, and I'll just test the waters at $99 and lose some money and then see what it really has to cost later. All right, so that's the Adoptabot CNC is what we're calling it right now. I'll get that off the table. So having been in the world of CNC this week, I resurrected some parts that were on my shelf. So check this out. This is the old Printrbot CNC, and some of you may remember this. I took it to some shows. I sold a few, not very many. Really, I missed I've gone over this in weeks past, so I won't belabor it. This runs on belts on X and Y, and then it runs on dual lead screws on Z, so it goes up and down. It's kind of an interesting design because when you roll it down all the way to the bed where it's cutting its material, you can kind of see the bars are here and the bars are behind here. There's 4 bars for Z and 2 lead screws. They're NEMA 23 motors, so it's pretty powerful, but it does have belts in it. So it was strong enough to, you could cut aluminum with this. Now that's true of a lot of CNC routers designed for wood. So it's not really that big of a deal. But CNC routers designed for wood typically have rigidity issues until when it gets down into the material deeply. So this actually is most rigid when it's at the deepest point. And it's technically least rigid at the highest point. But it's only like 3.5 or 4 inches, I forget. I think with your bit, it really restricts that. So there might only be 3 inches of travel on this. I forget. It's probably in the in the specs. But the point is, this uses really beefy rails, not Delrin wheels on extruded aluminum, which I think is cheesy. And it's what some of the beginning CNC routers, like, I'm trying to remember the name of it. Inventables sells it. X-Carve. It's just cheesy. No offense to Inventables, but that is not a CNC that could ever hope to cut metal at any speed that's respectable. So This one is better than that because it's all linear rails, really thick rails and carriages. It's, I forget the belt, XT belt. So it's a timing belt. So it's definitely rigid enough to cut faster than an X-carve. I mean, this thing is a tank. It weighs a lot. So why is it on the table? Well, I'm not selling this as an assembled version. I have, what did I say? I had 15, somewhere around 15 of these left. And I got out my parts and I noticed, well, I don't have the bars anymore. I've kind of eaten those up to do other things like the prosthetic printers. I don't have carriages to spare in stock right now. So I thought, you know what, those are available. If I sold this kit with everything needed to start cutting, the extrusion here, I use the FazTech extrusion. You know, I like that stuff. It's off Amazon. I would have to mark it up to make a profit on what I'm buying. You can buy that extrusion yourself. You can buy these rails yourself. Now, these rails, you need a grinding wheel to cut them. But here's what I'm going to do. I'm going to put together a bare bones kit for this. I've already done it. Dave's helped me. So we actually have a product. Is it online? It is available. It's only going to be 15 or 16 bare bones Printrbot CNC kits. And it does not come with the FazTech extrusion. You can save yourself money by ordering that yourself and cutting it with a chop saw. You cut it very slowly, but you can cut aluminum with a regular wood blade. So you can cut those down to length. And by the way, I've limited the Y on this to whatever this is. But you can order bar. You can order your own bar and carriages. And we'll put details of what bar and carriages these are. I recommend Highwind. They're really good. In fact, this is like a Chinese supplier. Highwind's actually better than these I have on here. These sometimes are good, and sometimes you get a carriage that's bad, and you got to throw it out. But anyway, the point is this 15 millimeter bar, and I'll tell you we'll have to put that in the notes, Dave. I forget the exact model number of the Highwind rail. It's the same stuff that's on the Z on the prosthetic. But anyway, or the Plus Pro. Anyway, so you can order your own rail and get a stock length and just cut your extrusion to that stock length because this Y is totally whatever you want it to be. And we will give you the plates. We're going to water jet some plates because I'm short on plates, but when people order, I'll cut the plates. And then I have all this nice powder-coated parts. I have all of the little bits to put together, the roller bearings and all this stuff to get all this moving. And I have the boards. So I have everything but extrusion, rails, carriages, router. So that's what you're going to have to source yourself. Now this is set up for I think we were selling a Bosch router with the Printrbot. Do you remember, Dave? If you look on the Printrbot page, you can see the router that we use. These are mounting holes for that router. But since you probably have a 3D printer, you could do an adapter plate that bolts right up to this. Or just drill this out. It's just aluminum, this carriage here. And you can have your own router. Now, it's $4.99. So these parts actually cost more than $4.99. All of the parts that you're going to get actually cost more to make than $4.99. But I want to clear the plate, get rid of that one pallet on my shelf that has these parts that are just sitting there. And we were selling it for, I don't know, $1,500 or something. I don't remember. But if you're interested in a very solid CNC, that Adoptabot CNC, while $99 is going to require a lot of work, this is going to require less work and be a better machine right out of the gate. But really, the way we built this isn't commercially viable. It's overbuilt for the market that I need to hit. So if you're interested in getting into CNC, didn't know what CNC to buy, for $500, this is a freaking steal. Now I got to get it off the table. No, I'm okay. It is a beast. Google has one of these CNCs. I just got off the phone with a guy that bought one and donated it to a school. And everybody says the mechanical design of that thing is ridiculous. It's really, really good. It's very sturdy. It's extremely robust. It's a tank. It's not aluminum extrusion and Delrin wheels. It's a real CNC. And up until recently, my discovery of CNC JS, it was lacking to run it on Windows because it runs a tiny, by the way, it'll come with a Tiny G V9 board, which I don't even know if you can buy. But that runs with CNC.js. And the V9 board is a little bit old. It's a dual channel USB board. You can change out the board if you wanted to, but it's really good. So you can plug it in via USB to your Mac or Windows or whatever. Use CNC.js. And that software was the thing that we've all been waiting for, something that is open source and free, yet doesn't suck to use. And what was that called? Chili Pepper does kind of work. It's buggy. And this, I think, is better. Chili Pepper ran on a Raspberry Pi, and it was kind of iffy. I've talked to those guys. They're great guys, and we have cut things with Chili Pepper. So that is one option. But just understand it's open source and a little bit buggy. The CNC.js seems to be a lot more stable and is not just for Tiny G, but even Marlin boards, Gerbil, and others. Okay. So you've next week you'll have a $99 option for a bare bones kit for an Adoptabot CNC. You have an option right now, only 15 of you, to get a $500 CNC that's probably worth $1,500. Can your CNC engrave acrylic very well? Oh, yeah. You want to grab that acrylic out of the window?
There's a video of it doing wood, acrylic, and aluminum that I just came across.
Okay. Dave is going to post a video of the Printrbot. Is it there, a blue acrylic? I used to have an acrylic piece that I cut. But yes, it will CNC acrylic, aluminum, and wood, no problem. Just got to adjust your feeds and speeds appropriately. And there's he's going to put those links to those videos so you can see this CNC move and work. Can you use a Harbor Freight router or one standard from a hardware store? Yeah, you just have to measure the holes, and you're going to have to either design or drill out. You can make a template from a piece of paper. I used to put the router plate upside down and poke a pen through the holes, and then put that piece of paper down on top and mark them and just drill it out. So yeah, you could mount a router from a hardware store. The reason I chose a Bosch for the Crawlbot was it had a cool Z adjustment. So when you start CNC, you've got your tool and you've got to home it. So what I would do is I would loosen the lever that adjusts the Z. So sometimes you have a dial on a CNC, so when you put a plate on the bottom to route something freehand, you can set it, and then you can adjust your depth up or down, and then you can route something. So that I used that plate because the Bosch router that I used had that adjustable Z. It came with it, and I kind of wish I would have used the DeWalt instead because it's the one that everybody says is awesome. The DeWalt 611, I think, it's like $127 on Amazon. That one is a few years old, but it's what Inventables recommends. A lot of the guys in the CNC forums use that one. I think the reason they use it is because they have this feature in that DeWalt that has adaptive speed control built in. So there's a sensor that monitors the speed. And when you take a router and like push it into the wood, it's under no load going to spin really easily. And then when you push it in the wood, it's going to bog. And kind of the RPM will drop. Well, it monitors that RPM automatically, and when it's under load, it'll like give it more power to spin it at the right speed. So without a spindle control on your electronic spindle control, which routers don't typically work with, traditionally it was like Mach 3 or whatever, but there's no way to easily hook up to your electronics to control the speed control. There is an open source project that took that DeWalt router with adaptive spindle control. Like you take the top off, you tap into it. I forget, if you do open source spindle control or speed control for routers, I forget what it is. I'll try to post a link for that. But it's expensive, but it's like this open source thing. I don't know if they did a Kickstarter or what, but you can hook that. It has a dial on it, has an LED readout. It's like a whole PCB, and it's pretty neat. And you can actually manually adjust the speed control. I think it's Arduino powered. Tap into that DeWalt, and then you got yourself a really nice speed control for your home router. So that's that. I need to learn more to really recommend all of these things with gusto. I don't want to choose your hardware for you, but I personally am going to find what I think is the best either spindle, and it may be a Chinese spindle, but I want it to work with the Tiny G board that's coming out soon. It has step and direction output. It uses trinamic drivers. It has the ability to hook up to those electronic speed controls and control the spindle speed. So that's really what I want, because I found out that it was back in the day when nobody knew what temperature to print at or what speed or what hot end to use and all that. It all kind of worked out to where there's kind of like not standards per se, but all of the manufacturers improve their hot ends, they improve their filament, and now you can kind of say, print PLA at around 200 degrees or something like that. The speeds and feeds of routing different types of material is very different, and you have to find that right speed. So when you have the chips coming off the material, like when you're making a part out of wood, the chips of wood that come off the router actually need to look a certain way. And when you're making chips, you don't want to make dust. You want to make chips. You want that router to cut by that bit, and there's tons of bits. You want that bit and that router to cooperate with that material in the way that it makes perfect chips. And then your router doesn't wear out. Actually, the mistake I made with the Crawlbot early on was I had the speed way too high and the feeds too slow. So that I was making dust, and I would burn out my router bits like that. It would burn out so quickly because it makes heat on that sharp edge, and it'll ruin it. So to be able to control speed of your router or spindle electronically is a huge help to getting life out of your bits and having the fastest speeds that you can travel and cut instead of just guesswork. And you're guessing when you're rolling a dial on a router. You're guessing. So a guy at a hackerspace locally that showed me that CNCJS, he had a tack, one of those laser tacks, tachometer. So he would paint a white stripe on the router and figure out what number on the dial. It went to 6, I think, which is random. But it went to 6, and he would map out the exact rotational speed. And I think he even measured it under load of plywood. And then he kind of mapped what speeds and what dials, so when he was doing certain feeds, he could get the right speed. So anyway, that sounds complicated, and it is. But electronic speed control using router bits that are known and in the library of Fusion 360 is probably a good idea to save yourself time. All right, that went a little bit deep. All right, so that is the 2 products so far. I got a third. So, paste extruders. So we made the Magic Candy Factory because a couple years ago, I was, maybe it's 3 years ago, I was fiddling around with an add-on paste extruder for the Simple. I just thought I really wanted to extrude clay. And we started testing with wall compound, like joint compound for drywall, because you could just buy it, you didn't have to mix it, it was there in a tub, and it dried solid. So I started messing around with that. And I built some really ugly, me and Mark, built a couple of really ugly like plywood and 8mm bar and like really cheaply. And this thing ended up being like that tall. It was really ugly. And you could bolt it to a Simple and use it. Well, because we had been messing around with that and we were open sourcing the designs, Magic Candy Factory from Germany, they still are around making candy with the printers that I made them. They used that idea to make this compound of it's like gummy bear stuff. But it was in a syringe, so it had to be heated. So I made this paste extruder and also did this for Print to Taste, the number 2, Print to Taste. And they actually did a Kickstarter that funded successfully because I said, sure, this is an open source design. I improved it from the plywood model. And they gave me feedback, and we got the firmware working. So little known to many, this was for sale for a long time in our web store. And it was pretty expensive. Do you remember how much it was? $330. That's expensive. So revisited that recently because This actually runs like a CNC. So there's no hot end. We had a heater in here, and it was a machine block of aluminum, very expensive to make. It had Delrin block pieces in here holding it all together. I had these injection molded gears, the Wade's gears that I used way back. So anyway, I had parts. This wasn't selling because it was too expensive. I sent one recently to Sweden because a guy wanted to do some confectionery printing, and he saw my model, and he's like, it's just so expensive, Brooke. It's ridiculous. You need to lower the price. So I sent him one for free, and then I realized, you know what? I do need to make this cheaper. Here's how I made it cheaper. I'm publishing all the files that used to be CNC machined. There were a couple crazy parts on here, like this part, this cool little spring-loaded, it was a lock that locks this into place. I was doing the BOM for this kit, so I'm going to sell a bare bones kit of the paste extruder. And that part right there is $10, believe it or not. Stupid. So instead, we're putting a quarter 20 bolt with a knob. So now you'll have to close it and screw in the bolt to lock it in. But what I wanted to do with this was, bring paste extrusion to 3D printing, and really I priced it. You see the theme here, by the way? I priced it. I built a really nice unit, made it in the USA, and people weren't willing to pay USA prices for top dollar stuff. Really, I've got a large audience of makers and people with that are very budget conscious. So all the mechanics on this are really nice, but I just cut out the heater, the Delrin parts, and these are all going to be published. That part's going to be published. There's a really nice aluminum stopper in here. What you do is I send 2 of these, and I gave the link to Amazon on this. I got a whole bunch of empty syringes from Amazon, different sizes, and I decided this is probably the biggest one that I'd want to design for. And so you pull out the stopper, take the rubber off the end, and you'll have a 3D printed part that goes on the end of this quarter 20 Acme rod. Again, old stuff. I use this on the old Simples. And you'll pop that on there with a set screw. And then instead of that long plastic piece here, which isn't very strong, you'll have a lead screw compressing based on this. I forget what the drive ratio is, but this is the wrong motor. I've got really powerful Kaizen motors that I used to use in all my old printers. I have some left. It's my most powerful stepper, NEM 17. So I'm going to ship it with the stepper. I'll publish the files. It comes with this aluminum powder-coated stuff, the rod. Actually, it's all here. The rod, 2 of these, the Kaizen. I got this machined insert to make these gears, which was originally moving 5/16 18, just threaded rod. Now, with this insert, this gear works for quarter inch 20. I think that's right. Acme rod. So you get these 2. This is a press-on. You get 2 end stops. You need them pretty long because this firmware that we modified has 2 end stops for, I guess you'd call it E-max and E-min. So the extrusion needs to have stop. You're at the bottom of the syringe. Don't destroy yourself. Or at the top, stop. You're at the top, and you can open your door now. Don't destroy yourself. So you need 2 of those. And then there's even a 3D printed part that you can utilize for the actual Z, because this has to move up and down. But it's kind of like CNC because you don't home or auto level when you start. You actually have to manually move, where do I want this to extrude? There's a little lure lock that goes in the bottom, so if you're using frosting or something, you put it like on top of the cupcake or whatever. And then you can set up your slice where, like, let's say it's at the center, that your slice was, the center is home. So and then it'll just, draw your words or put your icing on the top or whatever you're doing. If you're making cookies or confection or something. Anything that doesn't require heat, because this doesn't have heat. So anyway, it starts there, and there's no homing. You don't use the end stops. The only end stops that are being used are the E-min and E-max, so those come with it. Some hardware. Some of this is specialized stuff. This is Plastites. So it's designed to screw into 3D printed plastic parts, and it grips really good. You'll have to follow my instructions on, we want these Delrin parts to be very strong and have lots of material to use these Plastites with. So you will have to print it with high infill, so it's very strong. And then these beautiful plates. These are powder coated. The one that's on the bottom of holds the syringe at its, the bottom. Those right now are Plastites. We'll see how well that holds up on a 3D printed part, but it should be fine if you're using something that's fairly viscous. I don't know that this would extrude clay unless it's really watered down. So these are all of the parts right here that you'll get to make your 3D printed bare bones paste extruder kit. And all of these parts here, it goes onto an existing printer. You need to have a printer board for the firmware that I use, and we're using the Print to Taste firmware. It's really designed to bolt onto a simple. Do I have one? Well, I don't want to show you that one. Anyway, it bolts onto where the extruder went. So there's holes in the bottom of this that bolt to where the extruder goes. But that could be adapted to, a plus, if you've got a Prusa or whatever. You could use this on something else just to understand. You're going to have to figure out how to bolt it. But $99 if you want to check out. I got to turn off my alarms. $99 if you want to try out a paste extruder that is very, very, very nice, respectable, tested, works. Companies have been using this design for business. 99. Is that, or what, did I do 50? I kept saying 99. This is 49. $49. Only available now. Go. It's $50. Yeah, I don't know why I had 99 in my head, but yeah, this right here is $49. So 49. Now you're buying it, right? 99, you were like, ooh, that's a little much. But think about it. This is a lot of markdown. So am I losing money on these at $50? I don't think so. Maybe. But anyway, you'll have a good time, so check it out. So that's my 3 products. So I'll get these out of the way. Show you the next thing. Paste extruder. Maybe some of you will get the paste extruder. You'll buy the CNC, Printrbot CNC. You'll have some projects to do. It'll be cool. Maybe next week you'll buy the Adoptabot CNC kit. I'm providing some fun here. Well, here's another one. What is this? Well, I haven't talked about Printrbelt in, well, there's a long time I didn't talk about Printrbelt. And today I had this total epiphany. I called Bill and was like, Bill, I'm getting these crazy parts that don't look right. They're leaning forward. And he said, Brooke, what's your steps per millimeter on your Z? And I was like, I don't remember. So I said, well, I had Pronterface open, and I would move Z, 100 millimeters, and it's dead on. We're using a geared stepper driver for Z to drive this belt. You can still move it, but, it's a gear ratio. So it wasn't the typical, like 20/20 for quarter 20 Acme. 400 for TR8. We weren't using those values. We were using whatever the geared stepper values were. But I would say move 100, and it would move exactly 100. And he goes, Brooke, it's the hypotenuse of the triangle. So I told Mark, change the steps per millimeter on the Z on the Printrbelt to the hypotenuse. And he looked at me like, what? So he got it once I showed him. So this is, I'll be my little illustration, because this is a little kit, because this is going to be $1,500 when I finally get all the bugs out. Again, Bill at Polar 3D is like, Brooke, I'm having no problems with mine. It's running great. Well, we changed the design like 3 times, and now I'm playing catch up. But I thought $1,500 is too much. When I launched this, there was only a few people that bought it. And I thought it needs to be cheaper. So I did this little kit yesterday, and I don't have this in the store yet because I need to test it. And I already found a couple of problems. It's running into itself here and not triggering. This is on a simple. But by the way, it doesn't have to be bolted down to a simple. This could be bolted down to something else. This could be a plus. It cannot be a play, I tried, without significant, like hacksawing your play, because I need this gear here. I may have to move that gear down so it's a little bit more lower profile. But this is still a 6x6 bed. Since it's the hypotenuse of the triangle, the Z is actually less. But so it's probably more like a 6x4 or something. But anyway, the point I'm trying to make is this will be cheap. So I'm going to do a little bitty kit, bare bones kit. If you want to check out the Printrbelt, I'll have the material for the bed included in it because it's kind of custom stuff. You can get it on McMaster-Carr, but you got to buy a whole bunch of it. And I've got these gears. Ooh, that sounds wonderful. There it goes. Now it sounds right. It's rubbing on the sides just a little bit, so we may have to put some adjustments in there. I don't even have it screwed down. But the idea is take the Printrbelt little tester kit and put it on your Simple, or put it on your Plus, or put it on whatever you got. And this is the strange part. So since your Z here, normally the Z is like this changes the Z here. So I'm going to unplug my Z motor. Well, it's underneath. And I'm going to plug, this is my new Z motor here. Sounds wonderful. There. And this Z motor will drive that belt down. Now, to save money, to just get people using this, I did not include a heated bed, but I print with PLA mostly. It goes on fine to just tape. So I'm going to try this out without a heated bed and just blue tape. So maybe you'd be interested. Now I'll publish the files as well. Theoretically, you could 3D print all of this if you had a printer big enough. So first I'm going to do the laser cut wood or acrylic. This will probably end up being acrylic because it'll just look better. I'll do an acrylic kit and the motor, so you don't have to take the motor out of your Simple or whatever. Because how do I adjust Z? If I take away my motor, the coupler doesn't have anywhere to go, and it's just going to flop around. So you got to leave the Z motor in your printer. And you'll just hook the wire to the Z. And then I'll show you how to print with Printrbelt. It'll include I talked to Bill today at Polar 3D, and I said, hey, I got this little kit. He goes, oh, send me one. That's really cool. So I'm going to send him one, and he's going to figure out how to get you an account on Polar 3D, their cloud. So you won't be constrained to that, by the way. I know some of you you're not really interested in having an account on a cloud. Well, that's okay because there is already published out in the wild. This is open sourced. The post processor does work. It's just complicated. So you can do it. Some of you might even figure out how to do it in an Excel spreadsheet because you can take a slice and apply a post processor to it. Maybe you could write a little program. But he has one that he's already written and it works. So it's a 35-degree angle. So if you have a right triangle and a 35-degree angle, you can figure out, this happens to be, forget. I don't know exactly the dimensions of this, but let's say I had a 6 by whatever it is. It's a little bit more than 6. You can figure out this dimension. So once I changed the Z steps to hypotenuse, then I'm getting prints that look like they ought to be. Now I had some weird fan issue, and then I had a PSU issue. Ugh. Anyway, but this would run off of Polar 3D with Raspberry Pi. There's one, probably can't see it. But I have a Raspberry Pi that hooks up to my printer. There's also the option of using the plugin that he wrote with Octoprint. So if you have Octoprint, you have a printer laying around, you can put this on. You have Octoprint, then you can just get a plugin and run one of these Printrbelt things for the plugin. Why am I doing this? Well, I do still want people to buy this $1,500 printer, but I don't want to sell it before it's ready. And I really need more people to be using this with, the barrier to entry here is whatever it's going to be, $99. Maybe that's why I had $99 in my head. But maybe this is $50. I don't know what it's going to be. But I'm not going to lose money on these kits because they may be popular. I got to cut the acrylic and everything. So I'm going to put together these kits for next week. You can buy it. You will get instructions on how to use a Printrbelt on your very own printer. And then you can all try to help me solve these problems involved with these strange little machines. Because check it out, X and Y, or well, it looks like X and Y, but actually, oddly, this is Z, and Y still needs to be enabled. So it'll print out this direction, and your part will be skewed 35 degrees, and it'll go down. So I guess if you do something long, you'll have to kind of have it off the end of the table so it can go off onto the floor. Or you can tilt your printer up like this and have it come straight off. But anyway, so you have to use your Y here, and on this simple, I got to move the belt with the bed, and then you can kind of adapt it to use a Printrbelt. The thing I'm going to do is I'm going to use one of these kits. The first demo I do is I'm just going to have whatever, benchies, test cubes, I don't know. I'm going to have one part, and I'm going to say print that little part, and with the cloud, the Polar 3D cloud, you can line up a whole bunch of parts, but I want to see parts dropping off the end of this thing. That's the whole point of the Printrbelt. So kind of neat. So, I mean, I guess you could combine. You could put the paste extruder on here, and you could have you know, your little cookies come off the end. You can put your easy bake oven. That's another topic. But anyway, you could use this just to have fun, explore. It won't be a lot of money. So that's the, I don't even know what we call that. It'll be the Printrbelt kit. I don't know. Retrofit. I don't know. That's that. So that's what I got. That's what's been happening this week. Would you ever consider adapting a paste extruder to the Simple Pro? Yeah, this paste extruder actually could easily be adapted to a Simple Pro. The problem is I've got firmware for this that runs on the printer board. So slicing for this, totally possible, but you're not going to be able to get firmware that has the min and max. So you would discard those and just trust yourself. So when you extrude, it screws this down. So it might be a little finicky figuring out the G code. But this, you know, there was a platform on the old Simple that held your extruder. This one doesn't have that. It has, when you take this off the front, it has a flat plate. So you would have to just make an adapter that is an L bracket that bolts to that plate. And then it would work fine on this printer too. You do have to watch, you'd have to move it over to, or turn this handle 180. You don't want to hit this with your paste extruder. But let's see, you'd be right there. So yeah, you'd want to move it out to the side so you can go up. So when you go up to here, it's missing the handle. You see what I'm saying? It'd be really easy for me to do an adapter for the Pro for this, so maybe I should show that. I only have 50 things to do this week, so maybe I'll have Mark do that. But anyway, yeah, totally possible. This style of printer is designed for this paste extruder. So any other questions? I started really late because I was having issues with my power supplies. But what holds the old Z axis in place on Printrbelt kit? Oh, good question. So if you have your motor intact in here, I know this is a little iffy, but this has a quarter 16, or I think it is, Acme rod. You actually can leave it in place. It's not going to move. But I was going to put a clamp on this that like holds on to the bar behind it. I was just going to do a little clamp that you screw on. So you can loosen that, adjust your Z height manually, because I don't know if you can, whoops. I don't know if you can see, but the first layer actually has to kiss the platform beyond the radius of the turn, just slightly. So we put we put slots in here. That's why I had it loose. I was adjusting it front and back. So you can move this forward and backwards, and you can even like square it. You know, it moves a little bit. So once you get that adjusted, you'll be able to tighten those down. And then you will want to set your Z height here. That's one of the problems with this first model is I'm not getting clearance to hit my end screws, so I need to, or my end stops. So I need to figure that out. I had to add a little piece in here so that it actually, it's not doing it right now. There it is. I don't know if you can hear that. Click, click, click. I had to adjust my end stop. So I'm thinking about just drilling a little hole for a screw so I can dial that screw in and out to adjust my Y end stop so it stops at the right place. So when it prints, it can still home at the beginning. But when you home Z, that's not going to work. So what do you have to do to home Z? Well, this guy right here, I took out. And if I did control this manually, which is what I do to test it, before the print, I let it home X, I let it home Y, and then when it asks for Z, it starts to move this motor, the Z. I just go tap, tap with that, and then I put it back in there. So that's how it homes. But understand, it's not necessary to use the Z homing in the beginning of the print because the cloud just homes X and Y, and it assumes Z is at the right location because that's, in these printer belts, it's manual right now. So you just need to dial in this manually with this lead screw. And then once you're happy with it, boom. The nice part about having that motor disconnected is if while you're printing and you don't have the clamp on, you can go up or down manually so you get a nice bead on that first line. And then it'll start printing. So you can see that you do your first layer, and it's one line, and then it goes down from the tip. And it moves forward just enough so it knows how to print right on top of that at a 35-degree angle. So you build up layers. The layers start really thin, and then they get really fat. And this eventually will go all the way in, all the way to the end. Even though this has a 6-inch throw on the simple, because you've been printing on the hypotenuse, it won't actually print something. What is that? I don't have a ruler, but this looks like about 4 inches, so it's going to be somewhere around 4-inch height. So you could do 6 by 4 by infinite, or a whole bunch of small parts just rolling off the end. So, and believe me, it's new. It's non-intuitive. If you know 3D printing, if you just don't try to understand it, just use the cloud, then it'll work. Follow instructions and use the cloud, you'll be good. You have the best job. Some days I don't feel like that, but thank you. It's fun sometimes. When you do fun projects like this is what gets me excited. So name suggestion for the Printrbelt kit. PBDIY Printrbelt. Hashtag PBDIY Printrbelt. I like it. Printrbot DIY Printrbelt. That's cool. It will be open sourced, so you can call whatever you want, and you can go sell them. But my kit will be pretty cheap. It'll be hard to compete with that. So anyway, that's what I got this week. Anything else? We're good. Sorry I went long, but it started late. So I hope you guys have a great weekend. Go buy those paste extruders, CNC bare bones kit. Look forward to this kit and the DIY. I just call it DIY. The Printrbot Adoptabot CNC too. So see you next week. Take care.